Today we're going to try a Sec2 paper, Sec2 math paper from Betty Secondary School. So 1 hour 15 minutes paper. Let's see. Okay, expand a plus 3 and 2a minus 3. Okay, let's do this using the butterfly method, right? 2a square minus 3a plus 6a minus 9. And that is going to be equal to 2a square plus 3a minus 9. Okay, and then simplify that thing. Okay, so it's going to be negative 4x squared, and then that is going to be 16x squared, and then we're going to multiply them together. It's going to be negative 16 times 4. 16 times 4, it's going to be 64. 64 x to the power 4. That's it. Okay. 2a squared plus 3a minus 9 and negative 64 x to the power 4. Solve each of the following equations. Okay, this is a quadratic equation, kind of. Okay, so for this thing to be 0, we need one of them to be 0 because a number times 0 will give you 0. So we want p minus 5 to be 0. That will mean p is 5. Or we want 2p plus 3 to be 0. So that will mean 2p is equal to negative 3 and p is equal to negative 3 over 2. So p is equal to negative 3 over 2 or p is equal to 5. Alright, next one. X squared equal to 7x. Okay, so we want to just move it around, like move it to this side equal to 0, and we want to factorize it out. X times x minus 7 is equal to 0. So we can have x is equal to 0. If 0 is both sides, then yeah, it will be 0 both sides. If x is 7, it solves this. Makes sense, right? 7 squared and then 7 times 7. Yeah. So x is 0 or x is 7. 0 or 7. Factorize completely each of the following expressions. Right, we just use this method. Okay. 5w squared 12 negative 23w. So, well, 5 is a prime number, so one of them has to be 5. And how do we get 23? 2 times 6 is 12, but that won't help. Yeah, that won't be helping me. 4 times 3. 4 times 3. If you have 4 times 3 and both of them are negative, this will give you negative 20w, and this will give you negative 3w. That will give you negative 23w when you add them. Okay, so we have a can be changed into 5w minus 3 times w minus 4. For b, I see a common factor of, okay, let me just write down the question. I see a common factor of 2. I'll take that out first. So if I take out 2, it will be 25, and so it will be 25 c squared minus 98 divided by 2. It's going to be 49 d squared. Okay, now whenever I see squares, the identity of a squared minus b squared comes to mind. So it's like 5 squared here, 5c squared minus 7d squared. So now we know that a squared minus b squared is equal to a plus b times a minus b. I really want to show you guys where it comes from. Okay, let's just sidetrack a bit. This is fun. There's a square which has a area of a square, and there's a smaller square which has area of b square, and then the whole thing is a square, a times a. So if you're going to take away this square, we're going to left over with this area. So we want to change the area to something times something. I had this idea of moving it there. If you move it there, see, this is a minus b, and this is b. So we can put it such that there's a b here, and this is a minus b, a minus b. So I just moved it there. So what do we have? You have a plus b times a minus b. All we did was move it there, and we have the same area. So it's saying the difference of squares is this area, a plus b and times a minus b. Okay, yeah, I like doing that proof. Okay, 5c plus 7d times 5c minus 7d, and that will be it. I think I should write it down. Okay, 5w minus 3 and w minus 4. So we have this one, 2 times 5c plus 7d and then 5c minus 7d. Okay, solve this. Okay, I'll write it like this. 5z minus 1 is equals to negative 3 over 4. And now I'll multiply both sides by 4 times 5z minus 1. So both sides by the same number. The 5z minus 1 will cancel out. We get 4 times 2 times 4. And this one, the 4 will cancel. We have left over with this thing. So it's going to be negative 3 5z minus 1. Alright, so it's going to be 8 is equal to negative 15z plus 3. Move the 15z there. 15z is equal to 3 minus 8 minus 5. Great, so z is going to be negative 1/3. That's it. Okay, let's keep going. A map has a scale of that is to that. Given that the actual area, the actual distance between the two locations A and B is that. Okay, there's a distance there. Then find the distance in centimeters on the map. So we just have divide, right? So 14 km will become 14,000 meters, which becomes 2 more zeros to get centimeters because you times it by 100, right? So we divide this by 4,000. 400,000. Sorry, yeah. So cut. Oh, this is nice. It's going to be 14 over 4, which is going to be 14 divided by 4, 3.5. So it's 3.5 centimeters in the map. Okay, now given the area of the garden is 1.5 centimeters square. So people usually get confused here. They will just divide this or multiply this by 400,000, but that's not the case. So if you look at this, so how do I explain this? Okay, so imagine from the okay, you have a map and a square. Imagine a square. What is the area of the square in the map? It's 1 by 1, okay? But then in the actual world, it's like 400,000 and then 400,000 here. So you see a square just, the area of the square just, I know, like you square it at 400,000 square. So, and now imagine the actual area being made up by tiny little squares everywhere, like pixels everywhere. So whatever happens to the length, like if the length is being multiplied by 400,000, the area just becomes 400,000 times 400,000 because they're made up by all these tiny squares. So that's how I like to think about it. Okay, so area is going to be 1.5 times 400,000 square, but yeah, let's just do that. 400,000 square. It's going to give me a lot of zeros, but they want it in km square. I think it'll be better. I think it'll be better if we change it to km from the start itself. So let's do this. Map is to actual. We're gonna have something like 1 is to 400,000 centimeters is centimeters, but you change it to km there. 1 cm is 4,000 meters, which is 4 km. 1 2 3, yeah, 4 km. So now if we change it to area scale, area, so we're gonna have something like a map. If map is 1 cm square, the actual area is gonna be 16 km square. So this is good. So now instead of doing all this big multiplication and changing everything back, I could just multiply it by this much, 1.5 times 16. That will give me that in terms of km square. So let's do that. 16 times 1.5, that's just going to be 24, right? Yeah, 24. Okay. Yeah, okay. Yeah, 24. Kn square. Okay. The kinetic energy in joules of a particular object is directly proportional to the square of the velocity. So we're saying that the energy is proportional to velocity square. Given that E is equal to 75 and V is equal to 2.5, find the equation connecting these two things. So if they're directly proportional, it has to have like something like this. So when E is equal to 75 joules, when E is equal to 75 joules, I shouldn't be writing it, never mind. Okay, so I'll just sub it in, and V is equal to 2.5. 75 is equal to K times 2.5 square. Now I want to just find K. K is going to be 75 divided by 2.5 square. That's going to give you 75 divided by 2.5 square. 12. And K is 12. So we have an equation. E is equal to 12 V square, which is, okay, cool. The value of V in meters per second when E is that. Okay, we know what is K, we know the equation, we know E is equal to 12 V square, and we know V. So we just need to sub it in. Wait, no. Okay, so we know this equation, we need to find V. We know V square is equal to E over 12, which is going to be 432 divided by 12, which is going to give us 432 divided by 12, 36. And then V is going to be square root of 36. It will be positive or negative when you do a square root, which is going to give us plus or minus 6. But it doesn't make sense to have a speed that is negative, so we're going to have speed is 6 meters per second. But this is velocity, but never mind. Okay, let's continue on. Factorize that thing. So we're going to use the same idea of difference of squares, the a square minus b square, because you see 9 is 3 square. So x square minus 9 is the same thing as x square minus 3 square, which is same thing as x minus 3 times x plus 3. X minus 3 times x plus 3. Okay. Hence, find the two factors of that number of 2491 other than 1 and that itself. Okay. Why? Okay, we need to use, when we have such a problem, we need to use part A, wherever there's hence. So how can we find a factor? So we are supposed to use something like, they're saying 9 for some reason. So we need to use that idea of 9. Oh, okay, so to use the idea of 9, see this is like 9 less than like 2500. Oh, and 2500 seems like 5 square or something like that. Something like that. Let's try. It's actually 2491 is the same thing as 2500 minus 9. Okay, but wait, 2500 is just x square, right? I mean, it's 50 square. Yeah, it's 50 square minus 3 square. And then we're going to have 50 minus 3 times 50 plus 3. Great, now we have two factors. Okay, so it's going to be 47 times 53. So the two factors are 47 and 53. Okay. 4 workers can complete an assignment in 15 days. Assume all workers can work at the same time. Find the number of days it takes for 3 workers to complete. I think it will be good if you can form an equation. If you have more workers, it will take less time. You can do more assignments. If you have more days, you can also do more assignments. So the number of assignments is directly proportional to the number of workers, and the number of days. So the greater the days, the greater the number of assignments. The greater the workers, the greater the number of assignments you can complete. Okay, so using this relationship, let's try to find um the let's find a k. First one, you're given that it's one assignment, 4 workers, 15 days. One assignment, we have k, 4 workers and 15 days. So k is equal to 1 over 60. Okay, now how many days does it take for 3 workers to complete the same one assignment? 1, okay, so a is 1 and k is 1 over 60 and w is 3 and we have d. So we have d is equal to 60 divided by 3, 60 over 3, which is 20. We need 20 days to complete. Okay, let's try b. Same idea, same equation. Number of additional workers needed if the assignment is to be completed in 10 days. 10 days. To finish the assignment in 10 days. Okay, how many workers do you need? Okay, so when a is 1, number of days is 10, and the workers we don't know. Okay, so 1 is equal to 1 over 60 times workers, which we do not know, times 10. So we have workers is equal to 6. So we need 6 workers. We 1 over 6 and then we times it by 6 to both sides. So we have 6 workers are needed. But we already have 4 workers. So I think that's what they mean by additional workers. 2 more workers. Express that as a single fraction in the simplest form. Isn't the same thing we got in sec 1? Okay. Okay, a bit difficult. Okay, so we just need to multiply the denominator, like make them into common denominator, right? To get that, then you get 2x plus 1 times 3x minus 2. Okay, so this, to get that denominator, we need to have 3x minus 2. You have times it there, and then you have to times 2x plus 1 to the right hand side. So in total we have 3x plus 4x minus 2 plus 2. Oh, that's great. 2x plus 1 times 3x minus 2, and that's going to give us 7x. 7x over 2x plus 1, 3x minus 2. Okay, what else? Simplify that thing. Okay, let's try b. Simplify that thing. A cube b square c cube over 24 c to the power 4. We change the divide to multiply so we can swap them. 8c over a cube of b. Okay, so there's a cube here. Let me use pencil. Okay, a cube, bad idea. Okay, and then we have a b here, so this b is gone. We have 1, and then c to the power 4. So we can and there's like 3c and there's 1c, so we have all the c's are gone, and then 8. So we have b, we have 8, we have 24, but 8 and 24, this will be 3. So we are left over with this, b over 3. B over 3, and then that is going to be that. Okay, 7x over 2x plus 1 times 3x minus 2. Okay, let's go. Simplify each of the following expressions. So for fractions, always factorize to simplify them. Factorize out. If they have common factors, we can take them out. So we have n, that's a common factor that I can see immediately. It's going to be 2n plus 3. And then denominator, I can see a common factor of 2 at least. Like there's 2. I can take out 2. I can take out 4, because if you divide by 4 you have 6, and this will be 4. And I can then divide by 8 also. Yeah, 8. We can divide by 8. So it's going to be 2n plus, oh that's nice, we can cancel. I was expecting that to cancel, but now this is nice. Okay, so we'll cancel these two. We have n over 8. and over 8. Okay, again, factorize first. I see E in both sides, I see F everywhere, so I think the F will go away. So E cube I see from both sides, I see F square from both sides, so you're going to have E minus F. For this one, for denominator, I have E square at least to both sides and F cubed to both sides, and then we will have F minus E. Okay, so only difference is that this thing is a negative of this thing. Okay, let's take all the things that we know. We know this E will be gone. We're left with one E, and the F will be gone there. We have left with 1. And this one is actually, let me just write it down slowly. E over F, and then we have E over F over F minus E. But F minus E, we can swap it. We can times negative to both sides. So if you have take out a negative, it's going to be E minus F. So that will be gone too. So we'll be left over with negative E over F. Negative E over F, negative E over F. Solve that thing. Okay, to solve this kind of quadratic equation, if there is a zero here, we could have solved it immediately. If that's not the case, we have to expand it out and then solve it. So it's going to be x squared plus 3x minus 5x and then minus 15 is equal to 20. I move all the things to here. X squared minus 2x minus 15 minus 20 or minus 35 is equal to 0. Now we're back to quadratics again. X squared negative 35 negative 2x. Okay, x 5 times 3, no, 5 times 7, yeah, 5 times 7. 5 times 7, negative, so it should be negative here, so negative 7x and 5x. Yeah, there we go, works. X plus 5 and x minus 7. X plus, oh, okay, wait. So for this to be 0, we need this to be 0, or this has to be 0. X plus 5 is 0, which means x is negative 5, or x is equal to 7, right? Yeah, if you put 7 here, it's going to be 0. So it's going to be 5, negative 5, or 7. Given that that is that, find the value of p when q is that. It says subhidden, right? Yeah. P is equal to square root of 2 minus 5 over 2. I like it. Let's try something nice. Let's change it decimal, much easier. This is going to be negative 2.5. So P is equal to square root 2 minus 2.5. So it's going to be plus 2.5. And then you have 3 plus negative 2.5. Okay, so it's going to be square root. So 2.5 plus 2 is going to be 4.5. And then 3 minus 2.5, 0.5. It's going to be 4.5 divided by half. So it's like half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 9. So there's 9 parts to it. So it's going to be square root 9. So it's 3. 3, okay. And then Q, express Q in terms of P. Q in terms of P. So make Q the subject of formula. Alright, so I like this thing. Okay, so it's going to be P squared is equal to 2 minus Q over 3 plus Q. Now flatten the stack. Flatten the stack. It's going to be 3P squared plus QP squared is equal to 2 minus Q. Now move all the gems to one side, which is Q. Move all the Q's to one side. It's going to be Q plus QP squared, and the other ones to the other side. 2 minus 3P squared. Now filter out the gems, which is factorize it out. Q is 1 plus P squared, and then 2 minus 3P squared, and then throw the trash to the other side, which is the 1 plus P squared. We just throw it out the side, and then we're done. 2 minus 3P squared over 1 plus P squared. Done. In the figure below, ABC is congruent to BDE. Okay, got it. ABC is 90 degrees and this thing should be 90 degrees also. And then BED. is 50 degrees. Where is BED? BED. BED. They say it's 59 and then they say it's 50. Say it's 50 or 59. Yeah, okay. Or whatever. Hey, it's so hard to do it. Okay, never mind. AB is equal to 10. DE is 6. Find the BAC. Here we have contradictory informations. No, okay, never mind. Let's just get the idea. BAC. We have this thing. If you have this length, we can use Trigo to find it out. But we don't have that length. But let's see what else can we do given the thing. This is an interesting question. BAC, that thing, right? CD. Okay, so if it's a congruent triangle. Okay, it's congruent. So if that is 59, this is also something. This is also the same thing as that. So 59 or 50, whichever is correct. So we have this. It's gonna be 180 minus 90 degrees minus 59 degrees. So it's gonna be 90 minus 59. 90 minus 60 is 31 degrees. All right, then find CD. Okay, to find the total length, we can find the total length already, and then we can find this length also using Trigo. Yeah. Okay, this thing BC, we can use like a tangent, right? Because opposite over adjacent. So tangent 59 degrees is equal to opposite over adjacent BC. So BC is equal to tan over tangent 59 degrees. Okay, how about this? To find BD, given this thing also. Again, this is a tangent thingy. Wait a sec. Wait a sec. 59. If that is... Oh, okay, that's opposite. Never mind. False alarm. It's weird. Okay. This is 59. If they're congruent, this should be 10. Right. Don't need to do all this stuff. If this is congruent, it's going to be 10. And then what else is there? That is 6. This is 10. This is right angle triangle. We know this length also. We just need to find this length. If it's congruent, it should be 6, right? They say it's congruent, right? Let me see. It's congruent. Let me see. It's exactly the same. So we know this is 6. BC is going to be 6. And then, so done. CD is just going to be 10 minus 6. I should have not bothered with trigonometry. So it's going to be 4 centimeters. Did we learn? Oh, we didn't learn. Yeah, trigonometry wasn't taught till like sec to end. Okay, whatever. Decides to build a swimming pool in the house on a square plot of land of side x meters. Write an expression in terms of x for the area of the swimming pool. Okay, what is the area of the swimming pool? We know it's this length times this length. What is this length? It's x minus 2. So it's x minus 2 times x minus 4. Yeah. And then find the area of the swimming pool. Okay, the area of the swimming pool was found to be that. So we just need to equate it, right? X minus 2 times x minus 4 is equal to 80. Same thing as we did for the previous question. X squared minus 2x minus 4x plus 8 is equal to 80. Move everything to one side. X squared minus 6x minus 72. There we go. We got the answer. Hence, find the value of x. So again, this thing. X squared negative 72 negative 6x. X 7 and 8 and 9. No, it doesn't work. Let me think. 12 and 6 should be right. 12 and 6. 12 times 6 is that. Yeah, 12 times 6 is that. And then negative, right? So this should be the one that's negative. Yeah, negative 12x, 6x. So we have x minus 12 or x plus 6 is equal to 0. So for one of them, this should be 0, x has to be 12. Or for this to be 0, x has to be negative 6. 12 or negative 6. But wait, x can be negative 6, right? Because like it's an area length. So it's not negative 6, it's only 12. Rejected. Okay. Area. No. Find the expression. So it's just x minus 2, x plus 4. X minus 2 times x plus 4. No, x minus 4. Sorry for this tumbling around. X minus 4. Oh, another paper. Yes. How long did I take? I don't know. Okay, guys. I have the answer key with me right now. Like, you can't see clearly, but let's see how many marks I got. Okay, let's take a red pen. Got it. Cool. Okay, let's keep going. Okay, it's correct. Correct. Good. And then good. 3.5 and 224. And then 12v square. Yeah. And 6. Okay, you need to write plus minus 6. Okay, so minus 1. Okay. Okay, this is correct. This is correct and correct. Next one is 20 days. And 2 additional workers. Good. And then 7x over that thing. Yeah. And then b over 3. N over 8. E over f. 7 negative 5. 3. Good. Oh, no. Oh, it's perfect. Cool. Okay, so this is N over 8, is it? No, yeah, N over, huh? Okay, wrong question. Question number 13, okay. Oh, 31 degrees. Oh, cool. So it was that, okay. Oh, this is nice. Got full marks, yeah. 12. Okay, cool. Yeah, this was the answer I checked from. Yeah. Okay, guys. Thank you.